Hello and welcome to the TID Water and Power Podcast. I'm your host, Constance Anderson, and on this month's episode, we're discussing the district's Power Control Center. TID's mission is to deliver safe and reliable irrigation water and power. And while all district departments are working towards this mission, there is one area of TID that is central to making these essential services happen, the Power Control Center. 24/7, 365, holidays and weekends, the Power Control Center is managing our local power grid, monitoring irrigation flows, and more, ensuring reliability for our customers. And when an outage occurs, they're typically the first to respond to assist in restoration. On this episode, I'm joined by TID Power Control Center Department Manager Adam Labuga to discuss the role of the Power Control Center and its operators, the PCC's response in an outage, and how operations have changed with emerging technologies. Adam, thanks for joining us.
Right on, Constance. Thanks for having me. It's a pleasure to finally join your podcast.
Excellent. We've been looking forward to it. So if you would, start out by giving us a little bit about your background with the district.
Yeah. I'm a Turlock boy, born and raised in Turlock, live in Turlock. All my family's still in Turlock. I've always known about TID's reputation of the quality of jobs that they offer. And of course, hey, coming out of college, I want to get a good job, right?
Sure, absolutely.
So I applied at TID 3 times before I was offered a temporary position as an energy trader. So my journey is probably more unique than some of the other employees at TID. Start off as a temp. Nothing wrong with that. Had a college education, but no experience. Okay, great. That was October of 2012. So obviously I wanted to prove myself and become a full-time employee. And so finally in March of 2013, I was offered a full-time position in the energy trading division. So basically buying and selling power, and was up there for about a year and a half, in which I decided to take a different avenue to a different department. In January of 2015, I became an apprentice Power Control Center operator. So basically got a job that I was doing nothing with my degree with.
What was your degree in?
My degree was in finance and MBA in business.
Okay.
So, I'm kind of going into operations, doing nothing with money, and it was a whole new thing for me. But it was a great decision. Hindsight looking back, I enjoyed the energy trading division, but I enjoyed my department too. So January 2015 became an apprentice Power Control Center operator. So there's an apprenticeship associated with that. And eventually in January of 2018, I became a journey level operator, basically meaning that I was proficient to kind of make decisions about the assets and of the district. And, I enjoyed being an operator, working nights, holidays, and weekends. Eventually, I knew I wanted to get into the managerial side. So March of 2021, I was given an opportunity to become the Power Control Center division manager. And most recently, August of 2022, I was promoted to the Power Control Center department manager. So that's kind of my journey here at TID.
Oh, that's great. And you mentioned that the route in which you came to TID might be a little unusual. But I think you hit on something that we've heard from some of our other podcast guests, is that the position that you come into TID as isn't necessarily where you stay, that there's a lot of opportunity for movement within the district. And I think you're a great example of that.
Yeah. What I really want to emphasize is that the idea is that I applied 3 times to get a position at TID. So anybody that gets declined that first time, well, try a couple times more and maybe you might find some luck. You may be the absolute best candidate, but sometimes those best candidates get lost in the cracks of the whole process. TID is a great job to have. And I'm very thankful for that. But whether or not I was in energy trading or in the Power Control Center, still feel really good about, where I'm at today.
All right. So throughout your time at the district, as we mentioned, you've held several different roles within the PCC. But many of our listeners might not know what the PCC, and by that I mean Power Control Center, what the PCC actually is. Can you give us kind of a brief overview of what the PCC is?
The PCC is everything. Power Control Center, we aren't necessarily experts on one particular thing, but we have our finger in almost everything that goes on at the district. When somebody asks me like, well, hey, what do you do at TID? What am I supposed to, hey, I'm a Power Control Center operator, or hey, I'm a Power Control Center department manager. I'm a manager of this. What does that even mean?
Right.
The way that I can explain it is the Power Control Center operators are air traffic controllers for the electrical grid. And that's an analogy that I've used pretty much my entire career as an operator. People maybe have never seen what a air traffic control building or room looks like, but they kind of vision it, right? You're just kind of routing the planes, and we're essentially routing the electricity and water so that it could be safely and reliably delivered to TID's customers. The thing with that is people turn their lights on at 2 p.m. They turn them on at 2 a.m. With that being said, the operators are there 24/7, 365, nights, holidays, weekends, you name it, they're there. And they're there to ensure that the grid is being operated, that water is being delivered, that customer service is being conducted, that security is being monitored, and every other function that I'm sure we'll go over.
Yeah, absolutely. We're going to dig into each of these a little bit deeper.
Not to mention, these functions that I just mentioned, we do that for TID service area. But the operators also perform most of those same functions for Merced Irrigation District. It's not commonly known that we are the control room for Merced Irrigation District.
Yeah, that's interesting. Okay, so as the grid operator for the district, and as you mentioned, Merced Irrigation District, the PCC has a large role in outage response. When there's an outage somewhere in the district, what happens in the Power Control Center? What does that look like?
Yeah, it could be anywhere from complete and utter chaos to nothing goes on in there. For large outages, the control room or the Power Control Center knows about them. For example, if a line coming out of a substation is fully does not have electricity on it, right? All the customers that are off of that line are out of power. 99% of the time, the control room is going to know about it by getting a ton of alarms. Now, a ton, what is that? On average, we get about 1,500 alarms per day, and we're probably
wow.
And we're probably going to get maybe 10 to 15 alarms associated with that. So we kind of know when we have those big outages of 4,000 or 5,000 or 800 or 1,200 customers, however many customers are off of that particular line, we'll know about it. And so even with the large outages, ultimately, the goal is to restore power as safely and quickly as possible. So what does the control room do on those particular situations? We'll identify the area that is the problem area, or, for example, a car that hit a pole right in that particular spot. Okay, now we need to coordinate with the troubleshooter from the line department to isolate that particular area, meaning make sure that it's safe, those types of things. And then try to get the rest of the customers back in power by possibly rerouting some of the power. So rather than have 5,000 out, we're only going to have 100 out because we're able to reroute power and get the other 4,900 back in.
And I think that's something that a lot of people don't realize is when there is a large outage like that you guys have the opportunity to reroute that power, restore as many customers as possible, and really isolate where the trouble issue is.
For sure. Now, it sounds the coordination involved with the control room and the line department is huge on those types of things. So we're not able to activate the field devices in the control room. We have to tell somebody to actually go out there and do it. So those guys are at home. They need to get their boots on. They need to get their truck up and running to get out to that location. So it may take some time before we're able to isolate the area and then restore 4,900 customers and leave. Unfortunately, the 100's going to be out. And for smaller outages, we may not know that customers are out of power. And so that's why we rely on the public to call into the control room.
Oh, that's interesting. So if it's a large outage and many customers are out, like you said, we lose an entire line, that you're going to get the alarms on, you're going to know about that. But if it's a smaller outage, then you actually need our customers to call in and say, hey, I'm at this location and I'm out of power.
Totally. We depend upon the customers to let us know if they're out of power. That's why if you're thinking like, oh, my power's out, somebody will call in. Well, maybe not. Maybe it's only 5 customers that are in your neighborhood that are out of power and 4 of them are not home and you're the only one home. Nobody knows. We won't know. And so that's why it's very important that the public does call in when they are out of power. And if they hear a phone message that says, hey, if it's a large outage and you hear a phone message that says, hey, my area's out of power, well, then great. Then you know. If not, then you have somebody to relay that information to, and hopefully we can dispatch someone out to that area and get your power back as quickly as possible.
And what is that outage number that folks should call if they experience an outage?
Yeah, after hours, feel free to dial 209-883-8301 at any time to report any type of power outages or any type of electrical emergencies.
Perfect. Thank you for that. Okay, so a customer calls in to let the power control center know that they are experiencing an outage, and it happens to be part of a smaller outage. What happens then? Is it a similar process to what happens in a large outage?
Very similar. We'll forward that information to the troubleshooter, and once they kind of go out there, assess it. Maybe they can make some repairs to get those customers back in power. Maybe they cannot. Maybe they need a specific line crew to be called in from home and to go do maybe a bigger job than one troubleshooter could do, in which they'll notify that to the control room, and we'll end up dispatching that particular line crew to go out to that area, and they'll work hard to get those customers back as quickly as possible.
Is there a difference in the process if, say, the outage occurs at 12 noon versus 12 midnight?
Sure. So the way that we actually have a service division in which 7 a.m. to 3:30 p.m., their job function is to facilitate no power calls and dispatch the troubleshooters. After 3:30, their day is complete, and the control room takes over that function. So basically 3:30 p.m. until 7 a.m. the following day is considered after hours, and the control room will take care of those functions.
Okay. So it really doesn't matter from the customer perspective. They just need to call in, and you guys have got it handled as far as who's taking that call on the TID side. Yeah,
that's a very good point. Regardless if it's 12 noon or 12 midnight, give 883-8301 a call. If you're ever out of power, you have an electrical emergency.
Awesome. And then where can customers go to find information on existing outages? Let's say they've called in, they've let you know that they're having an outage. Where can they go for follow-up information on that?
Yeah, you can say you don't want to call in. I don't like being on the phone. You could always hit tid.org/outages. The control room or the service division will keep those outages on the website up to date as information flows in.
Perfect. Thank you for that. Okay, so we've talked a little bit about what the Power Control Center does, but it's actually a physical location. Can you kind of create a visual for us as to what the Power Control Center looks like from a physical standpoint?
For sure, yeah. The control room is probably one of the, I don't know if I want to say the most important, but it's definitely a high-level security place to get into. Prior to the Customer Academy, we've never had any of the public come into the control room. It's a very secure facility because think about the wrong person coming into the control room and taking down the electrical grid, taking down hospitals, emergency services, street lights, all those kinds of things. So it's a very secure facility. It was built in 2018, and we conducted parallel operations, meaning we basically started operating out of the new control room in 2019.
While still maintaining operations from the old control room. That's what you mean by parallel operations?
Correct. Yeah, just to kind of make sure, iron the kinks out. We didn't want to fully go to a new thing without testing it a little bit first, right?
Sure, absolutely. So what does the control room look like?
So the control room is a 3,000 square foot facility, and it's got a massive video wall, 12 feet tall, 40 feet wide. Of that are several 80-inch panels that consist of this video wall. We have 5 10-foot U-shaped consoles that are height adjustable and climate controlled for each individual operator. Upon each console has 10 28-inch monitors coupled with a 48-inch TV that we use for, more awareness. The facility's staffed 24/7. Like I said, like I previously mentioned, we're staffed 24/7, 365, all hours, minutes, seconds of the day. We have 3 operators on shift. We're conducting real-time operations. When you turn that light on, the control room sees it. We have a training room. The level of training that the operators need to go through is systematic. It's standardized, specific requirements from the governing bodies.
So you mentioned what sounds like this giant wall of screens. What sort of things would your operators be seeing on these screens?
Sure. So that's to give the whole room awareness, as each operator has their own 10 plus 1 monitor console. The big awareness on the screen is cameras. We monitor security after hours. So we have cameras. We have the weather channel up to monitor those types of things, especially during a big heat wave, a big storm. On the main 20-foot by 12-foot wall consists of a summary of the whole entire grid, in which the operators kind of use as a barometer to see how well the grid's doing. Okay. And then
I would imagine all this information is constantly updating around the clock.
It updates every 4 seconds.
Wow. Okay. Very good. That's a lot to keep an eye on.
Shout out to the EMS division for helping us out, updating every 4 seconds.
It's a team effort, isn't it?
Yeah, no doubt.
The new PCC sounds like a pretty awesome space, but that wasn't always the case for the Power Control Center. Can you tell us a little bit about what the old control room looked like?
So from what we came from was a 1,200 square foot facility that was built in the 70s. And just to date it, the walls were stained yellow from nicotine because back in the day, you could smoke cigarettes inside.
Wow.
No joke. The console itself was basically a lengthy, banquet style table in which we had 6 monitors on each, to mimic each desk. We still had 3 desks. It was very dated. So right now, the distribution map, meaning the map of the entire district that shows where every customer's power is coming from, is electronic. It's on these big TVs that I described. At the old control room, it was a 12 by 30 foot physical map in which you had to make adjustments that was operated by hand, meaning if a line was out of service, you had to physically go up there, erase that line, and conversely, if a line came back into service, you had to draw that line back in.
Wow.
It's very it's a relic, to be honest with you.
It sounds like kind of a cross between like a giant whiteboard and a giant bulletin board.
Yes, there you go.
Needless to say, your new location is a bit of an upgrade from the old.
Just a little bit.
Which it should be reassuring for all of our customers in the area, knowing that we've gotten a bit more sophisticated over the years.
Yeah, technology is only going to help improve delivering the water and power to our customers.
Right on. So you gave us a high-level explanation of sort of some of the duties that happen inside the PCC, but I'd like to get into that a little bit deeper. What can you tell us about kind of the different operations that happen inside the control room?
Sure. The main mission for the department, right, is very similar to the district, and that's to safely and reliably deliver irrigation water and power to TID's customers. With that, We conduct power operations, and the power operations aspect is to solely make sure that the lights stay on for the district, for all the customers. You didn't see any rolling blackouts in the middle of September when some of the other utilities were possibly looking into that or possibly dealing with that.
Sure.
TID was very secure, and that's just a testament to the power operations of the district, which includes distribution, transmission, generation. So power is just one facet of what the control room does, right? We also help facilitate irrigation water to TID's farmers. So that includes monitoring the water and canal flows from the upper system. We also, dispatch crews. We're doing customer service. The same style of the control room taking over for the service division at 3:30. The control room takes over for customer service at 5 p.m. also. So when a customer calls in asking specific customer service type questions, whether it's billing, new service, I need to make some repairs, so I need you to come disconnect my meter, those types of things. Control room's fielding those calls also. So it's important to stay, professional and represent the district very well. We also talk about monitoring security alarms. So TID has tons of assets throughout its footprint, right?
Sure.
Going to Patterson, going all the way to Don Pedro, all the way north to Tuolumne River, and all the way south to the Merced River. We keep an eye on those. We're here 24/7. We keep an eye on any types of alarms that come in over there. Somebody steps foot in there, generally speaking, the control room knows about it. Not to mention, we have the control room has the big picture of the district, especially for other projects or things like that. The interdepartment communication and coordination is very key for the control room to kind of spearhead that. We have various departments and they're experts at their various departments. Like I said earlier, we're not experts at any of their departments, but we're experts at coordinating and making sure that the big picture is being seen.
Again, kind of going back to that teamwork philosophy.
For sure. A collaborative approach. And that's what we have to have in the control room.
Absolutely. So tell us about these people that work in the control room. We know that they're there 24/7, 365, but what does that setup look like?
Yeah, some of the most highly skilled people in the world. No, there's a minimum of 3 operators on shift at all times. Okay, like I mentioned, and they work nights, holidays, and weekends. They work 12-hour shifts, a little bit more than 12 hour. They work 12.4-hour shifts, nights, holidays, and weekends. They're working from 5:36 p.m. until the following 6 a.m. You're spending Christmas Eve, Christmas night, New Year's night, Thanksgiving. You're having Thanksgiving dinner with the operators on your crew because 3 people have to be here 24/7 in order to help respond to after hours emergencies or even just basically the maintenance of the grid.
Sure, absolutely. So I want to double back to something really quickly because you mentioned that a typical shift may start at 5:36 p.m. and go until 6 a.m. That's kind of an unusual shift start. Sure. Why is that?
Well, it's kind of like we mentioned 10 monitors plus a big TV. Well, like everybody else, when you close your laptop and you bring it back up, it takes time to bring it up. Well, it takes time to bring up 11 different monitors. They each have a different kind of screen. So technically the operators are working 6 a.m. to 6 p.m. or 6 p.m. to 6 a.m. That 24-minute overlap is what the control room or the industry calls a shift turnover. That's very similar to nurses do their turnovers. I'm sure emergency services that work 24/7s, they also have their kinds of turnovers. It's basically for the shift turnover in which, hey, let's relay the pertinent information. Sometimes it's very little. Sometimes it's a lot. And then, hey, let's work on getting the 30 plus different softwares up that you need to operate the grid.
Sure. So it's kind of that opportunity to debrief between shifts.
Absolutely. That's a great way to put it. The overlap also helps ensure that there's no lapse in operations.
Okay, excellent. So what does it take to be an operator in the Power Control Center?
Yeah, what does it take? So there's a hiring process, and All of our current operators have been internal candidates. So they've come from they were perhaps experts at their various jobs throughout the district, and they decided to make a career change and come into the control room. They start out as an apprentice. So we have an apprenticeship that is 3.5 years long. It is 7 6-month modules. Okay. The apprenticeship is very in-depth, highly involved. It consists of field visits. It consists of on-the-job training, checklists, skills demonstrations, a ton of different readings, various classes that you need to attend, a ton of training, right? Basically a ton of training. And after each 6-month module, the apprentice is subject to a written exam and an oral exam that is basically an oral interview that is conducted by myself, the PCC division manager, the PCC trainer, and that apprentice's PCC shift supervisor. And we're just kind of asking questions that pertain to the job. So tell me how well you know your job, right?
That sounds like an intense training process.
It's very intense, but like I said, it's systematic, and it's specified in the requirements by the federal governing body for the electrical industry.
Okay. And I'm sorry, remind us what that governing body is.
That would be if you hear the acronym NERC, the North American Electric Reliability Corporation.
All right. So once you pass all of these, all 7 of these modules, then you are considered what?
Yeah. Once you pass all 7 and you obtain your NERC certification, meaning that the governing body approves of you operating the electrical grid in a reliable fashion, then you become a journey level operator. And with that comes a little bit more responsibility, but it also comes a little bit more pay.
It sounds like a big responsibility from where I'm sitting. Absolutely. So you mentioned that a lot of the operators currently in the PCC, if not all the operators in the PCC, have come from other departments within TID, similar to how you got there. What departments are these folks coming from?
Yeah, the control room is represented by a vast, diverse group of departments. So currently we have 16 operators. Some are apprentices, some are journey level operators, and some are shift supervisors. Of them, we have 4 from the trading and scheduling division. We have 4 from our power plants. We have 4 from our water distribution department. We have 2 that were substation techs. We have 1 from the service division, and we have 1 from the metering division.
Wow, that is a pretty diverse group.
Yeah, very diverse.
And I would imagine each of those people then brings their own background and, like you said, their own area of expertise, and has that to apply to their experience as an operator.
You got it.
Awesome. Is it unusual that so many operators would come from inside TID? Is that unique for a utility to promote from within like that?
Probably. But with TID being a smaller utility, we wear every department, right? Wears a lot of different hats. And I think the knowledge that the internal candidates are bringing from wearing their own hats within their departments, gels well with our group that we have, right? They could bring their expertise of the water. There's not many balancing authorities that provide irrigation water in addition to retail electricity.
That's a really good point. Absolutely.
So we have operators from water, we have operators from electric. Some of the operators, they came from somewhere else before that, right? We have some that came from customer service that went to water distribution that came here. We have some that came from meter reader back in the day to water distribution to in here. So they have very eclectic backgrounds.
Yeah, everyone with their own journey.
For sure, yeah.
Okay. So you mentioned that to become a journey level operator, you have to earn your NERC certification. What other sorts of certifications or trainings or studies must our operators complete?
So once an operator obtains their NERC certification, it's not like, hey, I'm done. I made it. I'm good. It's not like that at all. In order to maintain that NERC certification, you have to complete a minimum of 160 hours of continuing education hours every 3 years. So it sounds, I got 3 years. Sure. Go ahead and wait for that third year and try to get 160 hours in and train and do this and pass it and do all those kinds of things in addition to working your job. Right. So throughout the year, we have an excellent training program, and not to mention, TID specifically, has been approved to provide those NERC continuing education hours in which we can conduct in-house training and still get credit for those towards the operator certification. Not every utility has the ability to do that. So we're very fortunate that we can submit a plan to NERC, they approve it, and then we get the okay to conduct that specific training, and the operators get credit for it. They get hours for it. We are collaborative in our training. We've invited several other departments over to, hey, come take a look, come train. Let's do this. Let's help iron out some kinks. That interdepartment relationship, right?
Sure. Makes the whole system run smoother.
Yeah, a lot smoother.
Very cool. So I understand that operations in the PCC are organized kind of around 3 desks. Can you tell us what each of those desks are?
The 3 desks are, although they are differentiated between the distribution, the interchange, and the balancing authority desk, it's a collaborative approach to the team. And if someone needs help on the distribution desk, then the interchange or the balancing authorities definitely helping out.
So let's start with the distribution desk. What is the role of that desk and kind of what functions happen there?
So the distribution desk is pretty much where all the apprentices, that's where you're first going to start out at. And you're there for about a year. And it's a great opportunity then to learn the geography of the district. I came from energy trading. I mean, I have no clue about anything in a substation or anything like that. I had to learn it up real quick though, right?
Sure.
So the goal of the distribution operator is to operate and monitor TID's electric distribution system via the energy management system. So what does that even mean? What is this fancy technology stuff? Basically, if a customer looks outside and they see a wooden pole in a residential area, that's the distribution system. If they look it down in front of their driveway or big metal doors in the ground that say TID on them, that's the distribution system. So we're monitoring that. And that is at a specific voltage. That is at 12,000 volts. So we're monitoring, right? We're making sure the customers stay in power. We're fielding the customer calls to make sure everybody stays in power, type of thing. And I would venture to say that most people at TID and most of the public feel like that's just the main job of the control room. Okay. It's kind of like I had mentioned earlier, the public has never come into the control room. But not only that, there's plenty of TID employees that have never been able to access the control room. And it's not necessarily because we don't want them in there, right? I mean,
sure.
Love to show everybody around. But it's just not that feasible to bring, hey, let's have a show and tell type of thing.
Yeah, absolutely.
In addition to all of TID's customers on the distribution system, those green boxes or those metal plates in the ground or those wooden poles that are in your residential area, the control room also monitors those same things for Merced Irrigation District. We mentioned we're the control room for Merced. We monitor their distribution system also, and they operate at a 12,000 and 21,000 volt system. So during the business day, and after hours, if a line crew is working or troubleshooter's working, but mainly during the business day, you may see some linemen, some line department trucks working, making repairs, maintenance, fixing things on the various wooden poles throughout the system, or even in your own residential neighborhood where there aren't any poles, but there's underground wires. So the distribution desk specifically is responsible for giving these linemen special protections and clearances to safely work on the distribution lines.
So in short, they're going to communicate with the line workers and let them know, hey, this line is out of power. It's safe for you to do whatever maintenance or whatever work you need to do.
It's possible that the line could be out of power, but it's also possible that the line department is working on a particular line that is not out of power. So it's even more important that we ensure their safety by providing these special protections for them to use their live line work methods to safely conduct the maintenance, safely conduct the repairs, those types of things.
Absolutely. Okay, great. So
in addition to electricity, right? TID provides irrigation water. So the distribution desk, in addition to the electrical operations, also operates and monitors a portion of TID's upper water system. So we just wrapped up irrigation season a few weeks ago, and there's probably majority of TID's customers and employees that it's unknown that the control room is monitoring and operating, water.
Mm-hmm.
It's a control room. It's your grid operators. Why are you operating water?
Why are you operating water?
Why are we operating water? Well, we are an irrigation district first, right? And so the control room assists in bringing water down from the upper system so that the water distribution operators can take it over. So the distribution desk specifically assists in moving irrigation water from Turlock Lake through Hickman and allows the water distribution team to take it in their various laterals to provide the farmers with their particular irrigation demand.
You mentioned our Hickman small hydro. Does the PCC operate and monitor any of TID's other small hydro plants?
Yes. Throughout the upper system for TID, we have various smaller hydro plants that consist of maybe 1 to 5 megawatts. So specifically for the distribution desk, they're going to be operating the smaller hydro generators at Turlock Lake when the elevation warrants that. And they're also going to be operating the smaller generation out of Hickman. Not only do we operate these small hydro units for TID, but the control room, the distribution desk operates the small hydro units for South San Joaquin Irrigation District as well as Merced Irrigation District. So generating facilities such as Frankenheimer and Woodward, which are in Oakdale, we operate the generators, and South San Joaquin Irrigation District takes the water. The electricity that's produced out of those generators goes directly onto PG&E's grid. So essentially, it looks something like this. The South San Joaquin Irrigation District canal tender or water distribution operator, I'm not familiar with their job title, but their water distribution operator calls in and says, hey, I have my irrigation demand is 400. And we say, okay, we'll go ahead and give you 400 out of your system. And then they take it from there. The power that's generated eventually gets onto PG&E's grid. And the same goes for Merced Irrigation District. They tell us how much water they need. They call into the control room and say, hey, I need X amount of, the unit of measure for the water that we use is CFS, at least in our specific area. Hey, I need 1,000 CFS, and the control room adjusts the generators to ensure that the output is 1,000 CFS, and then their water distribution operators take the water from there into their various laterals and provide irrigation water to their customers.
So 3 unique organizations, 3 unique systems: TID, Merced Irrigation District, and South San Joaquin Irrigation District. 3 separate systems, but you guys are helping to operate each of those systems.
Correct.
Okay, that's a lot to keep track of.
Lot to keep track of. Especially during the water season, it's a lot to manage.
Sure.
But the operators do a great job doing that.
Absolutely. And let's keep rolling through the distribution desk. What else happens there?
We briefly touched on responding to customer calls after hours. So as I mentioned, after 3:30, we're receiving all calls that the service division would have fielded. And after 5 p.m., the control room's fielding all customer calls. After 5 p.m., essentially, the control room is answering every single call that comes into TID. And it could be anything from, hey, I'm out of power. Hey, emergency services call and said, hey, a car hit a pole. Hey, I think somebody's stealing power. any type of call, one of the operators in there has fielded everything. Any kind of call you can imagine. Very similar to everything else that I've mentioned. We do that same function for Merced Irrigation District as well. We take their customer calls, their out of power calls, all those kinds of things. We respond to and monitor TID alarms. So essentially, if we get any kind of alarm out in the field, out in any one of TID's assets, substations, or switch yards, we're dispatching our security team. They're kind of going out there to take a look, make sure everything's all good. And if for whatever reason we need other personnel out there, then we'll give them a call too. National Oceanic and Atmospheric Administration, we provide weather data to them. The energy imbalance market is something big that the district recently entered into. So essentially, it's a holistic approach to operating EIM, and the distribution desk is kind of like the second backup, if you will. We prepare and conduct switching orders during facility outage requests. It just means that, we talked about those big outages, those large, the 5,000 customers that are out of power. So the control room, it's not just, okay, do that. No, there's safety things involved. There's proper order. We're not trying to make the problem worse. So essentially, the operators will go through a step-by-step way of isolating that particular area or taking this element out of service. And the ultimate goal is to do things seamlessly where nobody's out of power, right? Sometimes we have to take a few customers out of power to get everybody back into power or those types of things. But the operators are essentially developing the plan and then forwarding that plan to the field personnel, whether it's the line department, the substations department, those kinds of things.
What is a switching order?
A switching order is essentially a plan. It's a step-by-step plan to remove a piece of equipment out of service or place a piece of equipment in service.
Wow, that's a lot that's going on at the distribution desk for sure. So now let's move over to the balancing authority desk. But first, what is the responsibility of a balancing authority?
Yeah, well, basically, the responsibility of a balancing authority is to meet the demand of TID's customers with some sort of supply on a second-by-second, moment-by-moment basis. And we could do that with our own generation, or at times we purchase power. The balancing authority desk is also responsible for meeting Merced Irrigation District's customer demand on that same moment-by-moment basis. So essentially, you're looking at Turlock Irrigation District and Merced Irrigation District as one big group together, and we have our demands and we have our supplies, and they have to equal one another every second of every day.
Okay. So does that mean that the TID balancing authority is separated from the rest of the grid?
So no, we're not necessarily separated from the grid. We are our own little jurisdictional entity, and everybody is tied with one another. The idea is that the sum is greater than one, right? If you're out by yourself, how are you supposed to get help from anybody else when you don't have your own internal supply? So if your generators aren't working or anything like that, how are you supposed to get how are you supposed to get help? So the idea is the lines that TID has are eventually connected all the way up into Canada. They're eventually connecting all the way through to the eastern edge of Colorado. They're eventually connecting all the way down into Baja California. And that's what comprises the Western Interconnection.
And what are some of the benefits of being a balancing authority?
Some of the benefits are things that we just kind of talked about. We can dictate whether or not we're going to have rolling blackouts for our customers. We can utilize our generation to create revenue, to provide affordability to TID's customers.
And it sounds like that local control really gives us a lot of freedom in how we operate, how we make decisions. Is that accurate?
It gives a lot of freedom. It also increases the responsibility and the scrutinization, though, also.
Sure. Absolutely. All right. So back to the balancing authority desk. What is this desk responsible for?
The balancing authority desk is commonly referred to as the transmission desk or the generation desk. Essentially, this desk is controlling the higher voltage lines. Now, higher voltage, if you look through the mountains or through the hills, or you see these big, tall metal lattice type looking towers, that is a high voltage line, meaning greater than the wooden poles that you see in your residential neighborhood. So TID operates at 69,000 volts, 115,000 volts, and 230,000 volts.
So when you refer to those higher voltages, you're talking about TID's transmission system.
Correct. Talking about TID's transmission system. Just like with many other job duties, we operate Merced's transmission system and also, which consists of the 115,000 volts. Because the criticality of operating the BES or the bulk electric system, apprentices generally don't sit this desk until about a year into their apprenticeship. And even at that, they're still being monitored because they're not NERC certified to operate on the bulk electric system. And so their shift supervisor is, kind of monitoring, even closer. So I mentioned transmission desk or the generation desk. This particular desk operates all of TID's thermal generation, meaning the Walnut Energy Center, the Almond power plants, and the Walnut gas turbines. So this desk also operates the larger hydroelectric generators. So they're basically operating Don Pedro, right? That's our only major large hydroelectric generation in the district. So we talked about the lower part of the upper system, if you will, on the distribution desk, meaning Turlock Lake and Hickman. The transmission generation balancing authority desk operates everything upstream of that. So this transmission desk is operating Don Pedro. We solely operate Don Pedro 99% of the time to facilitate irrigation demand and the Tuolumne River requirement. Okay. Many don't know TID and MID are responsible for the Tuolumne River flows, and that's facilitated through the control room. The control room gets these specific river orders saying, hey, I need the river to be at this. And this is coming from the hydrology department. So the water flows from Don Pedro to LaGrange to Dawson to Turlock Lake to Hickman. This particular desk, the balancing authority desk, is moving the water from Don Pedro. The water flows through the power plants, and TID customers get the electricity off of that hydro generation. The water's still moving to LaGrange. Now at LaGrange, can go into the Tuolumne River or it can go into TID's Upper Main Canal. At this point, it's where the control room facilitates water out of LaGrange into the Upper Main Canal system, which eventually flows through the system into Dawson, which makes its way into Turlock Lake, all through small hydroelectric generation. And then the distribution desk takes it out of Turlock Lake.
So you mentioned getting communications or orders from the hydrology department. What other departments is this desk in continuous communications with?
A lot of different departments. So I'd say the main communication consists between trading and scheduling division, definitely talking with the power plants, WEC, Almond, Don Pedro, the small hydro technicians, because we're still operating from Don Pedro to LaGrange to Dawson on the transmission desk. So LaGrange and Dawson are small hydro units in which, we're communicating with them. The substations department, the line division, electronics, tons of departments are the EMS department is very big. There's a ton of different departments that this desk is kind of talking with on a daily basis.
Okay. Is there anything else that we haven't mentioned yet that is responsibility of the balancing authority desk or the transmission desk?
I'm sure there's a ton of smaller things that the transmission desk is performing, but one thing that sticks out is we have software that conducts contingency analysis studies on a 5-minute basis. It's fancy,
what does that mean?
Fancy terms, right? Basically, what it's saying is that, hey, giving the operator awareness, situational awareness that says, hey, if you lose this transmission line, meaning if a bird gets into a specific line and causes it to lose power, what is that going to do to your system? I mean, if I'm just sitting on the transmission desk without any of those types of tools, I'm saying, I don't know. But this particular software is taking snapshots of the current state of the system and is running all of these different contingencies that could happen and is spitting out these results saying, oh, you're good. Oh, nothing's going to happen. Oh, shoot. Hey, this is going to happen. You better start thinking about things to mitigate that so that we can isolate the problem and not have a cascading event happen. Kind of like that domino effect, right? One domino goes down and keeps taking out the other ones.
Sure. So it's kind of almost like what if scenarios. And how would you recover from that?
Totally is what if scenarios. And it doesn't give you a solution, though. It doesn't give you a solution. That's where the operator has to intervene and say, let me use my experience, my intuition. Let me use my other tools to figure out on what my solution is. It's just letting you know you have a problem or you could potentially have a problem, right? Because it's running that what if scenario. But it doesn't tell you what you need to do.
Nope. The operator has to figure that out.
You gotta figure it out.
Okay. So you mentioned earlier when we were talking about the distribution desk, that desk is the second backup for EIM operations. So what can you tell us about the balancing authority's desk role in EIM?
Yeah, for sure. The balancing authority desk is the primary operator of the energy imbalance market.
And I'm going to put a plug in here that if anyone wants to find out more about the energy imbalance market, they can check out episode 15 of our podcast, where we spoke with TID's AGM of Power Supply, Dan Severson, about what EIM is and how it relates to the district. But briefly, can you give us kind of an overview of what EIM is?
So prior to EIM, TID bought and sold power on an hourly basis. So essentially, the trading and scheduling division would buy and sell some power a few hours in advance from the real time aspect, and it would come over to the control room on where the generators kind of needed to be, and is very very nonchalant as far as where the generators need to be. They just need to be online, and the system kind of solved itself. So we bought and sold power on an hourly basis. That's kind of the main thing here. So then here comes EIM, and EIM was a great opportunity to generate additional revenue and establish additional trading partners for the district. So now with EIM, remember we bought and sold power on an hourly basis. Now with EIM, we're buying and selling power on a 5 and 15 minute basis. EIM is basically trying to find the cheapest power for TID to satisfy its customer demand. Let me give you an example. So down in Arizona, the sun is booming. They have a ton of solar generation down there. The supply is greater than the demand. So they have a ton of generation via solar. And as a balancing authority, right, you're supposed to equal your supply and your demand. Well, if your supply is super high and your demand is average or lower, we have this excess generation. Well, what could you do? You could maybe lower your output of your solar panels or your solar farm, right? Lower your output. That's kind of defeating the purpose of solar generation. That was the old way. With EIM, we're here in Turlock. They're down in Phoenix. Okay. We're here in Turlock. We have our thermal generators. Okay. And they use natural gas. Okay. Natural gas costs money. So essentially with EIM, it's integrating the renewables, whether it's solar or wind, in order to help companies or utilities like TID to, hey, you know what? I'm in Arizona. I have this excess solar. hey, TID, you can reduce your thermal generation output. Now, maybe that company isn't going to sell it to us for, give us $20 and the power. Maybe they're going to sell it to us for $5, but it's still taking advantage of that renewable integration into the Western interconnection. So whether it's the wind in Montana or the solar down in Nevada or Arizona, EIM helps facilitate that 5 minute, that minute by minute type of output from those particular renewables. That's EIM.
Can you give us a quick look at what that looks like? What the process looked like prior to joining the EIM and what it looks like now?
TID joined in March of 2021, and essentially the way that the operators operated prior to March of 2021 is completely different of how they operate now. Equate it to here in the US, we drive on the left side of the car. Try driving on the right side of the car and see how you do. Might need to get used to it for a little bit, right? And we did. Fair. And we did. We had our growing pains, and now the control room, coupled with trading and scheduling, are doing a great job. The way we got there was a lot of training and a lot of collaboration. We meet once a week with trading and scheduling for about 2 hours to go over whatever we need to go over.
Awesome. Okay, so let's jump over to the third desk then, which is the interchange desk. What happens there?
So the interchange desk is also known as the shift supervisor's desk. So the shift supervisors also wear a hat in addition to the supervision of the crew. So shift supervisors will solely sit the interchange desk during the business day, meaning Monday through Friday, their normal day shift of 5:36 a.m. to 6 p.m. During the nights and weekends, the journey level operators will be given an opportunity to sit that desk, as well as some more experienced apprentices. They have the opportunity to sit that desk just for cross-training purposes. But essentially what the interchange desk is doing is that it's monitoring, TID's intertie stations. Well, what is an intertie station? Intertie station is basically a point in which we're tied to the outside world. So we have our neighbors, like we have MID, we have SMUD, or the Sacramento Municipal Utility District, or we have the California ISO. Maybe you've heard of them as the grid operators of majority of California. So we're all tied, as I mentioned earlier, we're all tied through the Western interconnection. Well, we're tied at specific points. So the interchange desk monitors transmission essentially outside of TID's area. If there's anything going on, fires up in the north, up at the border, they're kind of monitoring that particular area. An interesting fact that maybe some know, maybe some know, maybe some don't, is that back in the 90s, TID made an investment into some transmission that is at the California-Oregon border. In addition to that, we own a wind farm in Goldendale, Washington. So we're able to bring some wind generation down from Washington using those transmission rights that we procured back in the 90s. TID is tied to the outside world through our Oakdale switchyard, through our Walnut switchyard, and through our Wesley switchyard. So essentially, power flows in and out of TID through those particular points. So every hour, this interchange desk performs these checkouts. So what does a checkout even mean? So a checkout is essentially the accounting aspect to how the megawatts really flowed. So Constance, you and I, we did a deal, and I sold you 100 megawatts. Okay. And the way that I can equate it is, and like I said, I'm not a physics major by any means, but electrons move in the path of least resistance. The electrons want to go to wherever the demand is. Okay. We did a deal for 100 megawatts. And when at these various intertie points, we have meters that show, just like you have a meter at your house, the little round circle outside, maybe by your garage or what have you, goes through these meters and it says, hey, Constance, you actually, you bought 100, but actually you only got 98 of those megawatts. Okay. So would you want to pay for 100 megawatts or would you only want to pay for 98? Probably only want to pay for 98. I only want to pay for what I got.
Sure.
And so that's what the control room is doing by these checkouts. It's summing up how much of the deal actually got into TID's system at those various intertie points. And we do that with our neighbors. We do that with the California ISO, and we do that with SMUD, or the Balancing Authority of Northern California Bank. And we're doing that on an hourly basis. So 12 times a day, 12 times a shift, 24 times a day. We're performing those particular checkouts.
When the interchange desk is performing these checkouts, then what TID department are they working with to do this true-up work?
So the control room performs the accounting aspect for the checkouts on an hourly basis. And that information gets forwarded to our energy settlements department, in which, they cut the check or they get a check. I'm not sure, depending upon if we bought or sold megawatts.
So you guys confirm the receipt or the transmission of the megawatts for what was truly received or sent out, and then the settlements team kind of picks it up from there and handles the accounting side of it.
That's exactly it, Constance.
Okay, great.
They're also maintaining situational awareness over the Balancing Authority desk and the distribution desk. So they're helping out where they can. They're essentially the backup to EIM. So if that Balancing Authority operator needs to go cook some food, needs to talk to their spouse, any of those types of things, step away from their desk for whatever reason, well, the interchange desk or shift supervisor desk needs to be on point with the operations.
All right. So we've covered the 3 desks and the multitude of duties that lie within each of those desks. What are some other roles of the Power Control Center in general?
Yeah, some other roles. I mean, the Power Control Center department consists of the operators, but it also consists of outage coordination and PCC training. So outage coordination is exactly what it sounds. It's coordinating all of the outages throughout the district that are going to affect reliable operations of the control room.
And to clarify here, we're not talking about the car versus pole unplanned outage. We're talking about outages that we know the district needs to take for various reasons.
Correct. Outages that need to occur for maintenance or for testing, for inspections, for any type of thing that is something that is planned, that is foreseen, that is not forced or on an emergency basis. Any type of outage that is foreseen needs to get funneled through the Power Control Center department, in which we have the big picture of all the outages that all the various departments need, so we're kind of facilitating where it's going to be most feasible to conduct these outages in a reliable fashion, because ultimately we still want to make sure that we're providing water and power to the customers.
You wouldn't take the Walnut Energy Center out of production in the height of summer.
Correct. We actually have a policy that we pretty much limit planned outages anytime from May till about October.
That makes sense, when our load is typically less than in the height of summer.
Yep.
Got it.
Yep.
Makes sense.
And then we also have the training aspect. We have a PCC trainer because of the necessity to adhere to the NERC requirements. And in addition to keeping the operators up to speed on the changing industry, we have operators that have 15 years of experience or more. Come March 2021, that experience wasn't for naught, but they had to learn basically a whole new way to operate because of due to the energy imbalance market, right?
Okay, so we, as you mentioned, there were new processes and procedures that came along with TID joining the EIM. And I think that's kind of a constant with TID, is that we're always going to keep advancing. We're always going to keep looking for new innovations to meet future challenges. What are some of the challenges that the PCC is going to be navigating either now or in the near future?
Challenges are, the energy industry is always evolving. Even from when I got in the control room in 2015, things have changed, right? We just hit our all-time peak high of 735 megawatts on September 6th of this year. I mean, it's no secret. It was super hot that day, right? Everybody got that text message that said, hey, help conserve or your power is going to go out. Well, that may have been the sentiment for the rest of the state, but for TID, there was never a concern in which we're going to be losing our customers. Now we have localized outages, right? Hey, it's that hot. We have equipment that doesn't like the heat. Things happen, right? Cars that hit poles or whatever. Matter of fact, we're helping out the state as best well as we could. Given the amount of generation that we had. What are some other things that kind of keep me up at night, I guess? I think the state has some lofty goals in which TID has to be compliant with. We're talking renewable generation, 100% carbon free by 2045. I'm not sure that just basically means solar, batteries, and wind by 2045. Well, we have a lot of natural gas that we depend upon, natural gas generation, not to mention that natural gas generation provides the voltage support needed to move the megawatts from one place to another. Maybe this doesn't necessarily fall in my scope, but it definitely is something that's on our radar, and that's the no sale of gas vehicles. Electric vehicles in every home. That's if we just had an all-time peak of 735 megawatts, well, what's going to be our all-time peak in 2030?
Right. That's only going to drive that load higher. And how do you plan for that? Thankfully I'm not planning, but we're the end user of planning, right? We're the real time where the rubber meets the road and give us the plan. But that's what it is, right? It's a plan. So things change sometimes, right? Also, there's a ton of institutional knowledge within the control room. In any field, the loss of a lot of experience, it takes time to recover from that. The control room job, the PCC operator position, it's a 3.5-year apprenticeship. Okay. Well, does that mean at the end of 3.5 years, you become a journey level operator and you know everything? I can tell you right now. I mean, I've been at the control room almost 8 years now. I definitely don't know everything. And I'm here Monday through Friday, every day, seeing all the different stuff. Okay. These guys, the operators working nights, holidays, and weekends, they're working 7-day shifts, 7-night shifts, and a training week every 5 weeks. So they're not seeing everything, So the institutional knowledge that's going to be lost is definitely concerning. And it'll be nice to get some of our newer apprentices up to speed. But it just takes years. That's just what it is. It just takes years. Sure. And not everything can be taught in training. As you mentioned, you kind of have to see it. You have to experience it. A lot of on-the-job learning.
And that's exactly how it is with the control room. It's very similar to other technical jobs here at the district, right? We can name off plenty of departments that have apprenticeships and things like that. And it takes years to learn how to drive.
Okay, wow. So there's clearly a lot that is happening inside the Power Control Center. Is there anything else we haven't touched on yet that you wanted to make mention of?
Just want to thank you, Constance, for giving me the opportunity to do a podcast. I've had several of my colleagues or friends, hey man, when are you going to do a podcast? But I enjoy talking about the control room. I'm very proud of the control room, very proud of the job that we provide for the district and its customers. It's not an easy job to do, but the group of people that we have in the control room right now and the culture that we're trying to foster is on the up and up, and I'm very thankful for that. So I'm glad you can give me some time to put the Power Control Center in the spotlight and, in a positive light.
Awesome. Well, as a TID customer and TID employee, I'm certainly glad to have you guys in the control room doing what you do. So appreciate you.
Well, thank you so much.
Thank you for tuning in to the TID Water and Power Podcast. You can find TID on Facebook at facebook.com/TurlockID, on Instagram and Twitter at Turlock ID, and on LinkedIn as the Turlock Irrigation District. I'm your host, Constance Anderson. We'll see you again next time.